Our script then is working pretty well at accessing the contents of these get variables and using the names that we're passing through the query string to name those variables. However, what it's not able to cope with is any input beyond the simplest of characters. If we go back in here and we give a more complex name, if we tell our script that the name is Philip Brown, then we get a rather unfortunate URL encoded set of characters instead of the space that we passed to the script. So we have a bit of a problem here. The way we get around this is by using a function called the pack function. And we can do this by running a regular expression that's going to replace out those special characters. So the pattern that we're looking for here is a % followed by any of the hexadecimal characters that are used to represent those special characters when the query string is URL encoded automatically in the process of requesting the page. So we're going to set up a parenthesized subpattern within our pattern here to capture that data. We don't really care about the %. All the % tells us is that we're looking for a particular kind of data here that is not able to be passed on directly by using the characters themselves because it has to be URL encoded. So the kind of characters we're looking for after our % are 0 to 9 and A to F. And we'll include those lowercase as well, just to be sure. And we're looking for 2 of those characters, so that's the number that we're going to specify as the quantifier for that particular atomic element of our regular expression. Now that we've set up our pattern, what we need to do is we need to run the pack function, which is a predefined function which enables us to take the URL encoded characters and make sense of them. So we can simply use the pack function here as the replacement value, and we need to pass that these arguments. We use the hex function to capture what we pulled in from the pattern at the beginning of our regular expression, and we use the $1 variable to pull in that particular piece of data. That's our replacement value here, and we use the E for evaluate to make sure that this part of the regular expression is processed as Perl code rather than simply interpolating this particular meaningless string of characters to our data. We also need to include a G after that to make sure that the Perl engine will do this to every instance of the pattern, this pattern over here, that it finds. Now if you're not particularly following what's going on in this part of the regular expression, don't worry. You can use this method of doing it, or there are some easier methods which we're going to look at in the next chapter. It's important though, before we do that, that you realize a rough idea of what's going on under the hood. We'll do this regular expression not only to the values but also to the keys. So now if we go back to our web browser and try passing it the same data, it's able to correctly work out what we meant by the space and even other characters such as double quotes. You'll notice that in the address bar here it's made a bit of a mess of what we passed it as a query string. But nevertheless, by using those particular regular expressions in our script, we've been able to convert this back to a readable format.